Wave function collapse is an algorithm that can procedurally generate a much bigger output, be it an image or, in our example, a tilemap that resembles a smaller input tilemap in its overall structure. What is amazing about it is that we provide only one example input, and we can generate a lot of different outputs that all can look quite well. If you are wondering how it works and how to implement it in Unity, you are in the right place. Hi, I'm Peter from Sunny Valley Studio, and I will give my best to explain how does the wave function collapse algorithm works and how to implement it in Unity using object-oriented programming so you can end up with classes you can reuse in your own project. When I had first seen the algorithm at work, I was amazed on how it can create a decent procedurally generated output, even multiple good-looking outputs, based on a single input. We can see the results on screenshots. First one is Oskar Stolberg's game/tool that we will take a look in a while, and the second one presents how wave function collapse has been used to create bigger images or textures from a smaller one. In each example, we can see that the structure was preserved and the output reuses input information. I have looked at publications of how a wave function collapse algorithm works, but it took me a while and some experimentation to understand it better. That is why I have created this tutorial. I hope I can provide a good explanation on how wave function collapse works. First, let's see how it works on the already mentioned tool created by Oskar Stolberg. Here, we can choose a combination of tiles from the panel on the left and create a decent looking output image that uses those tiles. It will be shown in the panel on the right. So let's deselect all the tiles. We see an error, but when we select some tiles and click solve, we can see the algorithm has created an output image, and it can create multiple different outputs. This implementation of wave function collapse algorithm reuses pixel values in different spots in the image to create the output. So those are the information used by the algorithm. In our example, we will be working on a tool for creating bigger tile maps from a smaller one. The result might not be as impressive as Oskar's tool, but it implements the core of the algorithm. Let's see how it works. We can create different tile maps from this small input tile map. The algorithm can be tweaked by applying more rules so the output will be more presentable, but it all depends on what you need. The algorithm can work for any grid-based structure, provided you create an interface that converts your grid structure into a structure of generic values and provide an appropriate output interface. So this is one of the benefits of our example. You will be able to reuse the core wave function collapse code for your own projects, and the interfaces that I have provided for tile maps can be exchanged for anything you have a need for creating. Let's now see the course overview. This series of videos will cover the big picture of how the algorithm works on a higher level. Next, we will go through each step: reading input, pattern manager, core solver, and output creator, and how to implement those in Unity. At the end, you will have a working implementation that uses object-oriented design, allowing you to reuse the code for your own projects. So first part will be theoretical overview of how the algorithm works, and the second part will be coding from the reader input up to the output creator, and you'll end up with the tool that I have previously shown you. When working on this implementation, I have used few resources. I encourage you to check them out, as they might provide you with more information on the topic of wave function collapse algorithm. First, it's Oskar Stolberg's talk on how the algorithm works. The next two are articles explaining the algorithm. And also we are using Kenny assets for this presentation. All the files will be stored in a GitHub repository, a starting project, each step, and the result, so you can access the code for each iteration. I will try making multiple short videos, each focusing on a separate topic, so you can more easily go back to anything you might not have understood. So don't get scared when you look at the playlist length. All the links that I show in this presentation will be posted below the video in the description. But if for some reason they won't be present, please write a comment and I will post them there. In the next video we will talk about how wave function collapse works in higher level overview.